So hello everyone, welcome to my channel, and today I'll be talking about GraphRAG. So here's a question that will break almost every RAG system in production right now. So what were the downstream effects of the 2019 acquisition on the company's R&D strategy, and how did that influence their patent filing by 2022? So a vector search can't answer that. It will find a document about the acquisition. It will find the document about R&D. Okay, it will find the patent filing, but it cannot connect those dots because the vector search finds similar chunks, not relationships between the facts. So that's exactly the problem GraphRAG was built to solve. And in this video, we are going to understand exactly how it works, when you should use it, when you absolutely should not, and what Microsoft's new version, LazyGraphRAG, changed about the cost equation entirely. So let's get into it. So, so before we appreciate GraphRAG, we need to honestly think about where the vector RAG breaks down. So there are three specific failure modes. So the first failure is that the multi-hop problem. So multi-hop queries require chaining facts across the multiple documents. So like, what did the CEO of a company X say about the product that later discontinued? Okay, it requires connecting CEO with company X, and then company X with a specific product, and then a specific product with the discontinuation event. So there are four separate pieces of information potentially living in the four separate documents. So vector search will find the most semantic and similar chunks to your query, but the semantic similarity is not the same as the logical connection. So the chunks that are most similar to the query embeddings might be completely different from the chunk that contains the connecting facts you actually need. Let's move on to the second failure, that is the global query problem. Microsoft Research put the perfectly in their original paper of GraphRAG. Like, try asking a standard RAG what are the main theme across the entire dataset. So it cannot answer that. Okay, a vector search retrieves a subset of your documents. It is not a mechanism to reason over the whole corpus at once. So this is the query focus summarization problem, and it is genuinely hard. Okay, you need to need something that understands the dataset as a whole, not just find the local patches of similar text. Third failure is the lost in the middle problem. So when you retrieve multiple chunks and stuff them into a context window, the LLM consistently perform worse on the information buried in the middle of that context. So this is a well documented in research also. So vector RAG make this worse. So you might retrieve 10 chunks where only 2 are actually relevant, and the LLM has to wade through the noise to find the signal. Now let's screenshot this PPT for your future reference. So let's move on. So GraphRAG was introduced by the Microsoft Research in April 2024 and is built around a single insight. Instead of searching a similar text chunks, build a knowledge graph from your document and search that graph. A knowledge graph represents your data as nodes, which are entities, and edges, which are relationships. So instead of storing, the acquisition was completed in 2019 under CEO Jane Smith as a text chunk that you should search with a vector. So you store it as, there are three nodes. The one node is that acquisition 2019. Second is Jane Smith that CEO. Third node is R&D strategy. And the edges are Jane Smith and acquisition, in between there is completed. And another edge is acquisition 2019 influenced R&D strategy. So influence is the relationship. Now, when someone asks multi-hop questions, you don't search for similar text. You traverse the graph, you follow the edges, you answer questions that require connecting multiple facts because the connections are explicitly encoded. So let's move on to the GraphRAG's indexing pipeline. So here's what happens when you index a corpus with a GraphRAG. Okay, and this is important to understand because it's where all cost lives. Okay, so the step one is that we slice. So documents are cut into text units similar to the standard chunking. Step two is extract. Okay, an LLM reads the text unit and extracts the entities and relationships, which is expensive. Okay, there are LLM calls, that's why. Step 3 is the building the RAG. Okay, all entities and relationships are merged into a single knowledge graph. And step 4 is community detection. So the Leiden algorithm groups tightly connected entities into communities. Okay, a cluster of related concepts. Step 5 would be summarize. So an LLM generates a summary of each community at multiple hierarchical level. Step 6 is index. So both the graph and the embeddings are stored for query time. To give you more details about Leiden algorithm. So basically Leiden algorithm is a graph clustering algorithm. It finds groups of nodes that are densely connected to each other, but sparsely connected to other groups. So think of it as finding a topic island in your knowledge graph. So next, let's move on to the local search versus global search. So at query time, GraphRAG offers two fundamentally different search modes, and understanding this distinction is a key for you. So local search is like anchors to the specific entities mentioned in the query, then fans out through the graph to collect related context, best for who, what, when, where questions about a specific entities. And global search, it is for the uses the community summaries to answer the question that require understanding the dataset as a whole. Okay, reads the community report at multi-level of the hierarchy, generates partial answers from each, then synthesizes the final answer best for like what are the themes, what are the pattern exist, styles of question. So you can also screenshot this thing. Okay, so the graph rack pipeline diagram basically describes the how local and global searches work. Okay, let's go to the reality check. Okay, the benchmarks, what number actually says. Okay, so graph rack sounds great in theory, but does it actually work better, and at what cost? So let's look at the real numbers, including results from the Microsoft published papers and some honest limitations from the peer reviewed research. So where graph rag wins is that in global queries, okay, in global queries, Microsoft owns the research that showed a 70 to 80%, okay, comprehensive on global sense-making questions versus substantial lower scores for baseline vector RAG. Okay, second is the multi-hop, okay, accuracy. So 80% accuracy on complex multi-hop queries versus 50% for the traditional vector RAG. In AWS benchmarks, okay, or Latera in December 2024. Next comes the enterprise benchmark, 3.4x improvement on the enterprise question answering benchmarks, according to DiffBot 2023. Next comes search precision. So GraphRAG implementations in some production environment have reported search precision up to 99% for relationship heavy queries. So let's move on to the next slide. So where GraphRAG loses the honest limitation, this is where the most tutorials stop. So we are not going to do that. Okay. So the first one is simple factual queries. Okay, GraphRAG achieves 13.4% lower accuracy than a vanilla RAG on the standard factual benchmark like natural questions. Okay, according to Han et al. 2025. For simple lookup, you're adding expensive GraphRAG overhead for no gain. Next comes time-sensitive queries. 16.6% accuracy drop on questions requiring real-time or recent updated knowledge. So re-indexing a full graph is very expensive. Okay, it's not designed for the fast-changing data. Next comes multi-hop latency, while reasoning depth improves by around 4.5%. Okay, on hotpot QA, it comes to 2.3 times higher latency on an average, according to Zhu et al. 2025. Slower at query times. Next comes performance ceiling. So research show gain plateau at 5 to 15 million tokens as GraphRAG traversal becomes less discriminative with massive dataset. Okay. So the bottom line is that GraphRAG is not better than VectorRAG. It's better at specific class of queries. Knowing which class your user are asking is the entire decision. Yeah, so you have gone through this slide. So let's go to the next slide. That is the breakthrough. So basically the lazy graph, okay, the cost problem is mostly solved here. So the single biggest objection to GraphRAG has always been cost. Indexing 1 million tokens costs $20 to $50 in API fees and hours of compute. For large enterprises corpa, that's hundreds of dollars just to build the index before you have served a single query. So Microsoft Research dropped Lazy GraphRag in June 2025, and it's genuinely a big deal. So here's the core idea. Instead of pre-building the full knowledge graph at index time, Lazy GraphRag differs the expensive LLM-based extraction to query time and does it lazily, only for the part of that corpus that are actually relevant to the each query. So let me explain about the numbers. So for the indexing cost, identical to the standard vector RAG, 0.1% of the full graph RAG indexing cost is 1,000 times got reduced. Second is the query quality. For the local one at comparable query cost to vector RAG, lazy graph RAG outperforms every competing method, including the graph RAG drift search and long context vector RAG. Next, the query quality for the global one at 4% of the full GraphRAG global search cost, lazy GraphRAG outperforms all competing methods on both local and global queries simultaneously. And if versus 1 million token context window, Microsoft tested lazy graph against the vector RAG with a 1 million token context window, that is GPT 4.1. So lazy graph RAG still won on most of the query types. So this result that matters the most are that lazy graphs beat vector RAG even when vector RAG was given a 1 million token context window. So that means just a bigger context window is not a workaround for the fundamental retrieval limitation of vector search. So let me tell you how this lazy graph RAG works. Okay. So the lazy graph RAG combines the best first search vector RAG's strength, like finding the relevant chunk, with the breadth first search. Okay, so the graph RAG strength is covering the whole data set. So in an iterative deepening pattern. So it starts shallow and only goes deeper for the parts of the graph that matters for your specific query. The trade-off is that you it is controlled by a single parameter. So the relevance test budget is low budget, okay, and it is fast and cheap. And if it is high budget, then it is slower but more comprehensive. So you can tune this per your use case. And Lazy Graph RAG is now integrated with Microsoft Discovery and the open source GraphRAG library on GitHub also. So as you can see, it beats the 1 million token context window. Okay. Next comes, yeah. So the decision framework for you. Okay. Use it or don't, it's upon you. So this is the section that will actually save you time and money. Not everyone need GraphRAG. Okay. So here's the honest decision framework. Take a screenshot of this table for your reference later on. Okay, so the honest answer for most of the teams in 2026 is start with vector RAG, add a graph RAG or a lazy graph RAG. Okay, then for specific query types only, okay, where you can demonstrate it and outperforms, never graph everything blindly. The ideal architecture would be a query router that classifies the incoming questions and directs simplest factual queries to the vector RAG and complex relational global queries to the graph RAG. Several production systems are now doing exactly this. So let's move to the next topic. See the 2026 standard architecture, as you can see, user input, LLM query router, vector DB or lazy graph RAG, then synthesis generation is there, and the final answer. So let me tell you about some of the hot takes. The number one is GraphRAG is overhyped by people, okay, who haven't read the limitations. Even the tutorial shows that the case where GraphRAG destroys vector RAG on a multi-hop question. Almost none of them show the 13.4% accuracy drop on simple factual benchmark. So if a RAG system is mostly answering simple what is X, okay, questions, then the GraphRAG will make it worse and cost 100x more to index. So read the full benchmarks before you refactor. Second hot take is LazyGraphRAG actually killed most of the arguments against GraphRAG. Okay, the standard objection was always too expensive to index. Okay, so the LazyGraphRAG eliminates that. The new question isn't whether you can afford GraphRAG, it's whether your query profile actually needs it. Okay, so that's a much better problem to have. Next hot take is use a bigger context window instead of a GraphRAG if the GraphRAG doesn't work. Okay, this is the argument people make when they want to avoid GraphRAG complexity. Okay, Microsoft tested it directly. Lazy GraphRAG beats vector RAG even with a 1 million context window. So this issue isn't context size, is the vector search fundamentally. Okay, so you cannot represent the relation between the entities. Okay, so you can throw more token at the problem and it will still won't traverse a graph. And last hot take for us is the best RAG system in 2026 uses both not one or other. So the highest performing production architecture routes queries based on the type. Okay, simple lookups go to the vector RAG. It's fast, cheap, accurate. Complex relationals or global queries go to the graph RAG or a lazy graph RAG, treating it as a either or choice. Okay, that leaves the performance on the table. So this is the evaluation. Okay, so there was a problem with vector RAG that fractures on the multi-hop logic. Okay, and global themes. The paradigm of GraphRAG came explicitly that maps entities solving the complex reasoning. Then the optimization came with the lazy GraphRAG. Okay, collapses the $500 indexing tool to match the standard vectors. The smart routing architecture direct the traffic based on the query intent. Okay, so if you want to deploy the router, you have also given the commands that you can use. Okay, so you need to check where does the GraphRAG fit in your stack. Okay, drop a comment below also. And just to recap for you guys, okay, vector RAG has three failure modes: multi-hop, global queries, and lost in the middle. Graph RAG solves these by building a knowledge graph with explicit entity relationship connections and community summaries. It's not universally better. It loses on simple factual lookups and time-sensitive queries. And this lazy graph that came in June 2025 collapsed the indexing cost to match vector RAG while maintaining the most of the quality advantages. So the right answer for most teams is both with query router. If you want actually try this today, the Microsoft GraphRAG library is an open source on GitHub. Okay, point it at document corpus, run the index pipeline and try global query. The difference versus the vector RAG on what are the themes questions will be immediately obvious. Okay, so where do you think the GraphRAG fits in your stack? Are you already using it, or do you think it's an overkill for your use case? Drop it below. In the next video, I'll be talking more about various type of hybrid searches, BN25 plus vector search, reciprocal rank fusion, and when combining sparse and dense retrieval beats more both the individual. Okay, it's the retrieval upgrade that directly compromises everything we have covered in this series. Like the video, subscribe for the series, and I'll see you in the next one.